Welcome to the Principle of Electrical Circuits. You'll study important ideas that are used in electronics. This is the first electrical circuits theory as a fundamental courses that will base you on another lectures or courses on a higher semester. The first thing that we will learn is passive components. The first component in passive form is called resistors, and which will be introduced in chapter 2. Here is a pictures of resistors. There are two types of resistors: a single type of resistors and a packed resistors, which means that it consists of more than one resistors. The next passive component, or the second one, is called capacitor, which will be introduced in chapter 12. Here is a picture of a capacitor. There are many types of capacitor. Two of them are shown here. There are one mica and the other one is tantalum. Tantalum is a polarized capacitor, which means that its polarity is important, while mica capacitor is non-polarized, which means that it has no polarity. Inductors will be introduced in chapter 13. Here's some pictures of inductors, which you can find on power supply unit of a computer. Transformer will be introduced in chapter 14. Here's an example of a transformer. You can also find this in a power supply unit. Besides passive components, we know that there are active components. Active components are used in conjunction with the passive component to form an electronic systems. Example of active components are transistors and integrated circuits, or abbreviated as IC. Next, we'll discuss about the fundamental units in System International, or SI, in length, mass, time, electric current, which will be our main topics in these courses, temperature, luminous intensity or brightness, and amount of substance. Here are the unit types of each of this quantity. For electrical current, we use a unit called ampere. It's abbreviated by a capital A. There are some important electrical units, and except for current, all electrical and magnetic units are derived from the fundamental units. Current, charge, voltage, resistance, power. Current has a unit of ampere, charge coulomb, voltage volt, resistance ohm, and power is watt. We'll study now the meaning of each quantity. But before that, we'll study about magnetic units. You'll see this in the table here shown. The flux density, magnetic flux, magnetizing force, magnetomotive force, permeability, and reluctance. Tesla is the unit for flux density. Weber is for the magnetic flux. Magnetizing force is ampere meter per meter. Ampere turns per meter. Magnetomotive force is ampere turn. Permeability is Weber per ampere turn meters. While the last one, reluctance, is ampere turns per Weber. The symbols are shown on the slides accordingly. Now we're talking about scientific and engineering notation. Let's look at the example. 47 million is written in scientific notation as 4.7 times 10 to the power of 7. While in engineering notation it is written 47 times 10 to the power of 6. In engineering, we will always have a multiple power with a multiple of 3. So, for example, 10 to the power of 0, and then 10 to the power of 3, to the power of 6, 9, etc. While in scientific notations, we have a standard that say that the base number will be started with 1 point before the decimal and more than 1.2, 3, and etc. numbers after decimals. Here's another example to clarify how you write 0.000027. In scientific mode, it's 2.7 times 10 to the power of minus 5, while in engineering, we convert minus 5 into minus 8, so 27 times 10 to the power of minus 6. Here's another examples of 0.605. In engineering, we have a prefix for our measurement or metrics. Now, can you name the prefixes and their meaning? For P, for T, for G, M, and little k. Here are the answers and the corresponding power of 10. And here is another metric prefixes: small m, mu, n, p, and f. Stands for milli, micro, nano, pico, and femto. Here are the power of 10 accordingly. Next, we'll study about this metric conversion. You might use to already in line, for example, if you have to convert kilometers into meters or centimeters into millimeters. For electrical, we will also use this kind of metric conversion. For example, 0.47 mega ohm is equal to 470 kilo ohm. So a larger number and a smaller unit corresponds to the left hand side. Here's another example of capacitors. And here's metric arithmetics. So how to perform additions or subtractions or multiplications, and how does it affect the prefixes. Here another example, how to do arithmetic for two different metrics of ampere, one in micro and one in milli. You can either bring the milli down to micro or the other way around. Here is the other way around. Now, in every chapter, we'll study about terms. Terms is very important in the study of engineering. A clear terminology will help you understand the specific meaning of each term. So let's start with the engineering notation. What is an engineering notation? It's a system for representing any number as a 1, 2, or 3-digit number times a power of 10 with an exponent that is a multiple of 3. So there you go. We have take a look at some of the engineering notation, and this is definitions or descriptions about what is an engineering notation. And then the next term will be exponent. Exponent is defined as the number to which a base is raised. Metric prefix is a symbol that is used to replace the power of 10 in numbers expressed in scientific or engineering notation. That's why we use M for milli or capital M for mega. Scientific notation is an alternative to the engineering notation, and by definition, scientific notation is a system for representing any number as a number between 1 and 10 times the power of 10. That's definitions of scientific notation. In every chapter, we also have a quiz, about 10 questions. Try to do this quiz in class, and at the end of the slides there will be an answers, but try not to look at the answers yet until you have answered each of the 10 questions. This ensures that you have gained some knowledge about the previous slides. Thank you for following with me in this first chapter of ECT, Electrical Circuit Theory, in our department Computer Engineering of Technical Faculty of Binus University. My name is Jimmy. Thank you for listening.